Welcome to our first edition of Journées Scientifiques, Inria, Chile. On this occasion, I would like to start by welcoming our authorities, the Minister of Science, Technology, Knowledge and Innovation, Mr. Flavio Salazar, the Subsecretary, Ms. Carolina Gainza, the French Ambassador in Chile, Mr. Pascal Teixeira, the Directeur General Délégué à la Science, Inria, Mr. Jean-Frédéric Gerbeau, and the CEO of Inria Chile, Nayat Sanchez P. Today, we'll start the Journées Scientifiques, an event of 4 days organized by Inria Chile to share the results of successful projects and to discuss more about science and also technology. As a link between two great nations, France and Chile, Inria Chile invites you to learn more about their great achievements, innovations, and their contributions to science and technology. This is a remarkable moment that allows us the opportunity to share experience and results, and that is why the first edition focuses on fostering a rich dialogue and networking among the participants. This event will hold activities such as scientific sessions, an innovation session, a roundtable, etc., to allow us all to discuss some very exciting topics such as artificial intelligence, the Internet of Things, applied mathematics, oceans, climate, biodiversity, astronomy, energy, health, and open science. Now, I would like to hand over to our host today, the CEO of Inria Chile, Mrs. Nayat Sanchez P., for her welcoming words.
Hello, are we live?
We're live. Good morning.
Hello, good morning. Welcome to our Journées Scientifiques Inria Chile 2022. Thank you for the introduction. I want to start by welcoming the Minister of Science, Technology, Knowledge and Innovation, Mr. Flavio Salazar, the Subsecretary Carolina Gainza, the Ambassador of France in Chile, Son Excellence Pascal Teixeira, and the Deputy CEO for Science at Inria, Mr. Jean-Frédéric Gerbeau. Dear professors, researchers, colleagues, friends, and all of you who are with us in this special occasion, welcome. It is a great pleasure for me to inaugurate the Journées Scientifiques Inria Chile. We are living incredible times in digital sciences and technologies. We are experiencing a technological revolution that is transforming and redefining humanity. This is the case with artificial intelligence and machine learning, which are disruptive technologies that are transforming society, our behavior, and our well-being. And this is also the case in other digital areas like the Internet of Things, modeling, simulation, human-computer interaction, and other emerging ones like quantum computing, just to mention a few. For developing countries, it brings the opportunity to jump into a new economic equilibrium, increasing economic growth and speeding up development. And this progress has brought important advantages and has served as a conveyor belt to the creation of whole new business sectors. It's hard to imagine how this revolution will unfold, but Inria will certainly be at the center of it, as Inria produces high-impact research results in the domain of digital technologies, and also by articulating the connection between the academic world and industry with the vision of a common good, social well-being, and ecological concerns. This year, we celebrate the 10th anniversary of Inria Chile. During this decade, Inria Chile has been the catalyst of more than 130 programs and projects of scientific research, innovation, and technological development, where more than 600 researchers from Chile, France, and other nationalities have collaborated. In this decade, we have built a joint French-Chilean institution, Inria Chile, that has consolidated the great bilateral collaboration between France and Chile in digital sciences and technology. Around high priority access for both countries, such as artificial intelligence, biodiversity and the oceans, astronomy, health, precision agriculture, energy, and with a strong commitment to doing so by promoting a more ecologically viable technology. We deeply appreciate the support we have received from both governments. Having an institution like Inria, one of the world's leaders in digital technologies, is an advantage for a young institution like Inria Chile, and I want to thank the commitment of Inria and its president, Bruno Sportis. I want also to thank the visionary support of the Chilean government through Corfo, through ANID and the Chilean Ministry of Science. I want to take this opportunity to thank the support through all these years and the future, as it has been and it will be essential. Similarly, we are very grateful to the Chilean academic community professors, researchers, and students who have welcomed and embraced us here, as well as the many Inria researchers who have been involved in the creation and also in the evolution of Inria Chile. We also appreciate the support of the local industry with whom we have been successfully collaborating. Collaboration is at the heart of both countries' science, technology, and innovation strategies, and together we want to advance in the construction of a stronger collaborative scientific and innovation models. The Journées Scientifiques Inria Chile 2022 is a 4-day event which celebrates this decade of international cooperation and its fruitful results. We gather here to present the most recent wave of results of this collaboration. Besides the presentation of these results, we count on excellent keynote speakers who are important researchers from Chile and France and other interesting initiatives. In this regard, I want to especially highlight the launching of the Inria French-Chilean Network of Research, which we expect to become an important means to foster and promote the collaboration links between our two countries. We had envisioned this Journées Scientifiques also as a moment for personal encounter. However, the COVID-19 pandemic has pushed us to organize this meeting in fully online form. But nevertheless, as a digital sciences institution, we have done our best to ensure a productive and satisfactory meeting with many virtual activities, even during the coffee breaks. This would not have been possible without the decisive support of the program committee, the organization committee, and the whole team of Inria Chile that has supported this both directly and indirectly. And I want to take this opportunity to personally thank you, all of you in Chile and France, that have gone an extra mile to ensure the success of this event. Without further ado, I would like to invite you, all of you, for the next 4 days of the Journées Scientifiques. We have a very intense and interesting agenda. Do not hesitate to have an active participation, to comment, to discuss, and hopefully, despite the distance, also envision new directions for research and collaborations. Enjoy the Journées Scientifiques Inria Chile. Thank you.
Thank you, Nayat Sanchez P, for that introduction. Well, a society that acknowledges science and also understands the importance of research, it's a visionary society that can take into account the necessities of today, designs also valuable solutions, and foresee the future. It is within this context that I now introduce you to the Minister of Science, Technology, Knowledge, Flavio Salazar.
Okay, Mr. Pascal Teixeira da Silva, Ambassador of France in Chile, Mrs. Nayat Sanchez, CEO of Inria Chile, Mr. Jean-Frédéric Garbeux, Deputy CEO for Science. I'm Flavio Salazar, Minister of Science, Technology, Knowledge, and Innovation, and I want to send a warm greeting to the participants in the Chilean-French meeting organized by Inria Chile, named Journées Scientifiques 2022, an event involving French and Chilean scientists and engineers to discuss and learn about the advance in digital science and technology on topics such as artificial intelligence, Internet of Things, applied mathematics, oceans, climate, biodiversity, astronomy, and open science, and promoting international collaboration, especially between Chile and France, being this one of the major aims of Inria Chile. Inria Chile celebrates 10 years anniversary. It's the first center outside France operating since 2012. Its mission is to maintain scientific excellence and impact from science and technology, economy, the environmental and society in this set. Its actions are strongly linked to international collaboration and open science. From our government, we are very focused in promoting international collaboration to improve our own scientific and technological capacities and valorate very much our standing relations with France and their scientific community. I wish all of you a productive meeting. Thank you.
Okay, we're back on. Thank you, Minister, for your words. It is very important that us, as a society, we can offer tools to empower our communities and foster also economical and social growth. It's within this context that we celebrate the bond between Chile and France. I will introduce you now to the French ambassador in Chile, address you with a few words.
Bonjour à tous. Good morning to everyone. Mr. Flavio Salazar, Minister of Science of Chile, Mrs. Nayat Sanchez-P, CEO of Inria Chile, Mr. Jean-Frédéric Gerbeau, Directeur délégué à la science à l'Inria, representatives of the French Ministry of Science and Research, dear speakers of this Journées Scientifiques. I am proud to be with you for this opening of this Journées Scientifiques. Inria Chile has been active for 10 years. I would like to congratulate it because it has worked intensively to promote French, Chilean and Latin American scientific and technological development, facilitating and enhancing bilateral Franco-Chilean collaboration. Inria Chile is a catalyst of 130 programs and projects of scientific research, innovation and technological development, where more than 600 researchers from Chile, France and other countries have collaborated in. Inria's Chile's contribution to bilateral cooperation in areas such as artificial intelligence, for example, are aligned with the execution of the roadmap agreed by Chile and France in 2018. This is a contribution made by the Chilean National AI policy presented last year. These are essential challenges for our societies. In addition, Inria Chile stands out for its vocation for gender equity, a pending task in the world of science and technology, with joint research teams and always promoting women's participation in its teams and projects. This event, the Journées Scientifiques Inria Chile 2022, represents a great opportunity to showcase the efforts and achievements of this international cooperation and to project the future. It's important to underline that Inria France is one of the most important public scientific organizations with public funds. At the same time, Inria Chile receives public funds from Chile and from France, and we are very proud of this. Science and innovation are a strategic aspect to take care of biodiversity and fight against climate change, to help understand and expand our knowledge of the cosmos, and to allow us to be more efficient and improve productivity in areas such as health, agriculture, energy, and many others. This bilateral collaboration between France and Chile through Inria Chile must continue to promote innovation and digital sciences and technology, allowing a bilateral contribution to the global challenges facing humanity. I wish you excellent Journées Scientifiques.
Thank you, Mr. Pascal Teixeira, the French ambassador in Chile, who greeted us at the start of the Journées Scientifiques Inria Chile. International collaboration is forged in moments like this, when we settle on the same objectives in order to promote societies together. Inria, it's a public institute of research on science and also technology under the close supervision of the French Ministry of Higher Education, Research and Innovation, and also Ministry of Economy, Finances and Industry. Today, we welcome the Deputy CEO of Science at Inria, Mr. Jean-Frédéric Gerbeau, who will address us right now.
Hello, can you hear me?
Yes, we can.
Okay.
How are you?
So, great. So I'm very pleased to introduce today the first Inria Chile Scientific Days. Of course, there were many scientific meetings organized over the past years, but to my knowledge, this is the very first Inria Chile Scientific Days. And by chance, as was already said, this happens on the occasion of the 10th anniversary of Inria Chile. 10 years of existence and successful activities made possible by the support of Corfo and ANID to CIRIC program, and also thanks to our partnership with Chilean universities. I've seen that most of them, of our main partners, will be presenting during the next session. Successful activities that were also made possible thanks to the French embassy and also to the French and Chilean ministries that have closely followed the development of Inria Chile. I would like to thank them all for their continued support. Since the audience is diverse today, I would like now to say a few words about Inria. Inria is the French National Research Institute for Digital Science and Technology. Inria's historical motto is scientific excellence and transfer. Inria has moved new frontiers in research, innovation, and entrepreneurial risk in France and in Europe for over 50 years. We like to see the Institute as a bridge between academia and industry. With more than 3,500 scientists, 200 project teams, most of them being joined with the universities, we covered most of the fields of computer science and applied mathematics, programming languages, data science and artificial intelligence, mathematical modeling, control optimization, telecommunication networks, software engineering, robotics, etc. This diversity of topics is the strength of the Institute, and we consider it essential to preserve it. Nevertheless, in our strategic roadmap, we have selected a few priorities for which we have sought dedicated funding. First, in AI, which in our views covers the wide range of scientific topics, symbolic AI, machine learning, data science, and hybridation with other approaches, like physical modeling or formal methods. Second, cybersecurity. Third, quantum information technologies. Fourth, high-performance computing, with a special attention to the algorithms and programming for future exascale machines. And then we have a few major application sectors, such as personalized medicine, precision agriculture, sustainable development and energy, and lifelong learning. This is not a surprise. Several of these strategic themes are reflected in the projects carried on at Inria Chile. As already said by Nayat, you can find, for example, several projects in AI and applications in astrocomputing, environmental challenges, marine energies, agriculture, and so on and so forth. The interest for Inria to develop some of these topics in Chile is clearly the excellence of the Chilean research. On a personal level, I had the chance to be part of the program committee of the Chilean Millennium Scientific Initiative for several years. And I have seen a large number of proposals at the highest international level, in mathematics, computer science, which shows an extremely dynamic national community. The recognized scientific excellence of Chilean research was clearly one of the reasons why Inria decided 10 years ago to develop this ambitious and unprecedented program to have an office in Chile, firmly anchored in a rich history of scientific cooperation. This is really an exceptional choice for Inria, as we have very few places in the world with such a representation. As it will be illustrated during these scientific days, in the spirit of Inria motto, Inria Chile is now a place where are carried out both research and innovation projects. Our ambition is to continue and expand our activities in Chile, in research and in innovation, both in conjunction with major Chilean universities and in collaboration with companies established in Chile. I would like to thank the program and organization committees, and of course the team of Inria Chile for the organization of these 4 days, and I wish you a very successful meeting.
Thank you. Thanks to all authorities today accompanying us, Nayat Sanchez P., Mr. Flavio Salazar, Mr. Pascal Teixeira, and also Mr. Jean-Frédéric Gorbeau. We invite you to review the program of Journées, Scientifiques and the activities for the next few days. First, remember that the Journées Scientifiques is a 4-day event. Each day will be divided into 2 parts, separated by the coffee break. You must be registered beforehand in each part in order to participate. I was telling you about how to register. So let me repeat this information. To register, you have to access program, and next to each day, there is a link in red, which you should click to register. 5 minutes before each part you register in, you will receive an email with the link to connect. Remember that each link is unique and also personal. Please check your emails to get access to the link of each part you are registered for. Some of the activities prepared for this occasion are to present opportunities to get to know better about this French and Chilean cooperation. Today, we will begin with the launching of the Inria French-Chilean Network of Research. Tomorrow, we will have presentation of French and Chilean research models and also ecosystems. This will be on Tuesday, May 10th at 8:40 a.m. That is to say, the first part of day 2. Then on Wednesday at noon in Chile and 4 p.m. in France, the presentation evaluation of research software source code, software heritage will take place. To finish our Journées Scientifiques on Thursday, May 12th, Nayat Sanchez P. will be moderating a roundtable in which we will talk about open science. Well, let me refresh. Along the 4 days, we are going to have 4 keynote presentations guided by outstanding French and also Chilean researchers. Also, we will have a dedicated session to innovation where successful cases of transfer and innovation will be presented. This is on Tuesday, May 10th. To end up, we will have scientific sessions all along the 4 days where joint French and Chilean projects will be presented. Last but not least, we want to remind you that at the moment of the coffee break, we will meet at GatherTown. This is an interactive segment in which we want to promote the networking between the participants and also where the work of some of the Chilean interns will be presented, in particular, their international research experience at Inria. The interns we will present are a selection of the alumni of the Inria Chile internship program, who have experienced the chance to go to France by enrolling in this program and to conduct a research internship at Inria. Let's welcome our new young actors in this field and accompany them. And now we will continue with the launching of Inria French-Chilean Network of Research. This is very important for us. That will be presented by Cécile Bigoruk, Director of International Relations at Inria. She will be accompanied in this presentation by Claire Saint-Leger, Head of Americas at the International Relations Department at Inria, and with Luis Martí, Science Director at Inria Chile. We leave you with Cécile Bigoruk, Director of International Relations, Inria.
Hello.
Victory. Hello. Sorry. Sorry for, I apologize to everyone, but I had to switch borders. So my name is Cécile Vigouroux, and I thank Daniel for the introduction that I could catch before I was kicked out. So I am very happy to be able to say a few words today about the launching of the Inria French-Chilean Network for Researchers. And first of all, I want to thank the organizing committee for giving us some time from the very beginning of the scientific days to be able to say a few words about it. And for me, the important word is network, because of course, as already mentioned previously, there have been a lot of collaboration already ongoing during these last 10 years, but ongoing still today. For example, we have the collaborating research project called Associate Team Program at Inria, and the associate team with Inria Chile ranked number 3 among the number of the associate team that we have with all the countries all over the world. So the collaboration in research is really very important already, and not only with the associate teams, but also with all the project AMSUD in which Inria Chile is involved with other countries in Latin America, and of course with the first challenge with international partners, the Ocean AI challenge, and there will be a dedicated session, if I'm not mistaken, in the coming days on this challenge. So we already have a lot of collaboration, bilateral collaboration and multilateral collaborations. But we really want to capitalize on these interactions and to build a network in which French and Chilean researchers will be able to interact, to give new ideas, to give also new ways of collaborating with their colleagues at Inria towards Chile, because for us, Inria Chile is really at the core, in the middle of all the collaboration that we want to build between Inria and Chilean academic partners. And for us, Inria Chile is really the academic hub through which all the collaboration between Inria and Chilean academic partners will grow. So that's why I'm very happy today that we can have some extra information to give both to Inria researchers, but also to the Chilean audience about the network. And so I'm going to leave the floor for a duet, so to speak, for the presentation. First of all, I will leave the floor to Luis Martí, the scientific director of Inria Chile, and then Claire Saint-Léger, the international partnership officer at Inria, that will work very closely with Luis to animate and to dynamize this network with a few words. So Luis, the floor is yours. Thank you very much.
Well, thank you very much. By the way, I started sharing my screen, so I cannot see any of you. Can you tell me if it's been properly shared and all of that? Yes or no?
Yeah, we can hear you and we can see the first slide. So
okay,
far.
awesome. Yeah. Thank you very much. Well, thank you, Cecile and Claire, for inviting me to be part of this session. Can you see the slides full screen?
Not the second one. We're still on the title.
This is really strange. Let me reshare everything. This is too sophisticated for me. Give me a second. I will just share the whole screen and see how it goes. So now you should see the whole screen, and you should see it better now.
Let's try for the second one. Yeah, no,
okay,
no. Now
awesome.
it's like
yeah. Okay.
yeah.
Yes. We had more fun. By the way, let me know if I am running out of time, because again, I am unable to. And this thing, bear with me a little bit.
It's working. Yeah.
Awesome. Well, let me take 10 seconds to say hi to everybody present. In particular, Nayat, you, Cecile, Claire, Jean-Frédéric, all the authorities and all of that. It's a pleasure to to talk to all of you. So actually, this is for us here in Inria Chile, this is a very important step, because we have been implicitly building this network for the last years around the construction and the consolidation of the cooperation between France and Chile in the areas of digital technologies. And this has led to a very intense and very fruitful international, not only between France and Chile, but also including some other countries of the region, in which Inria Chile has positioned itself as a hub for, or let's say, leverage to foster and incubate this collaboration. This has led to a set of very fruitful collaboration and research actions between, as I say, different countries and different teams also in France, because part of the mission of Inria Chile is also to allow, let's say, fortify or reinforce the connection between many-to-many connection, in which we are, let's say, organizing or facilitating this connection in the center. No, so as I was saying, there are many Inria teams involved in working with Chile, thanks to that, and also with other countries of the region. And this has been articulated around the idea that in order to foster scientific collaboration, we also needed to have scientific activities in Chile and to serve as, let's say, as an interface between the two countries. And we have been developing this idea. Chile is a very particular country in many aspects. When we are talking about computer science and applied mathematics, of course, Chile is a very appealing country. You have all these astronomy installations that are set up here and allows and creates a big challenge for computer science in particular, because astronomy is as almost any other science, I have to say, are heavily related to computer science and relying on computer science, and particular AI, image understanding, and you can guess all of that. Then Chile is also a natural lab, an ideal natural lab for understanding environment and climate change. We have been working a lot of that. Then the Chilean industry is very important, in particular in mining. So there are many opportunities for, let's say, setting up collaboration programs around this. You can imagine logistics, a lot of autonomous vehicles, robotics, Internet of Things, all of that. I was mentioning logistics also because Chile is if you are into logistics, Chile is a paradise, no? Because of the very nature of the country, where it is located, how it is conformed. Then there are areas like agriculture that in Chile have been very proactive into incorporating technology into the agricultural processes, smart agriculture and all of that. And of course, for example, health is also a big issue, taking into account the characteristics of the country and all of that. So as I was mentioning, the mission of one of the missions of Inria Chile is to serve as this articulation. And the way we have set up this is by having a research. Inria Chile is Inria, so we have a research program set up in which we articulate and run different projects. Some of them involving, actually most of them involving different Inria teams, also Chilean academia. We have a strong relationships with many universities and research institutions here. Then also with the Chilean industry, because as Jean-Frédéric was saying, let's say the spirit of Inria is to also related to the transfer of technology. So it was a perfect introduction for this. And also we, as let's say, as we are here in Latin America, it's also part of our mission to also, let's say, help incubate any possible collaboration activities. And that's why we have many research projects that not only include Chile and France, but also other countries like Uruguay, Argentina, Paraguay, that I can remember now. By the way, this is a very summarized version of all the activities that we had. In the previous slide, it was shown in more detail. And of course, not only with France, but also with Europe and global. We have collaborations with institutions from Korea, from in the US, and all of that, because at the end, well, computer science and almost any science is actually an international affair, no? So in this context, and with this principle of, let's say, interacting with local academia in Chile, and also interacting with Inria teams and serving as this connector, we have started to identify potentials where Inria teams, Chilean academics, and Inria Chile can spin out or spin off different research projects in different directions. No? Although the formal focus and the topic areas of research of Inria and Chile are, by the way, the same or a summarized version of Inria's very own research lines, we have as we are a relatively young team, we are growing step by step, and currently we have a focus on a subset of those. It doesn't mean that our interest or activities are restrained to this, but we are working in this area related to ML, artificial intelligence, machine learning, and Internet of Things, human-computer interaction, optimization, and this kind of stuff, a lot of modeling and simulation. And this is mainly driven by this, let's say, positive cycle in which we identify research projects that where we can collaborate ideally both with Chilean academia and Inria teams. Sometimes it's not a perfect loop, but we aim for that. And using these projects, we, let's say, extend our local activities and get ready for further projects. And so we have like this chaining of products. Like, for example, we have been working smart agriculture project like frost forecast, and this is about the detection of anomalies in climatic anomalies, and we have reused this knowledge, for example, for discovering black holes in an astronomy project, and this is now being used to discover to identify fires using drones, and this chaining of let's say creating a strong opportunities for academia, both here in Chile and Inria teams, reinforcing the team locally so we can face bigger projects and make this cycle even bigger and reinforce this positive loop is more or less the spirit that we are been trying to build here. So, by the way, all of these projects, you will have a presentation from them in the future. And as I was mentioning, we have many active and let's say actively ongoing collaborations with Chilean institutions with the Universidad de Chile, and in particular the Center for Mathematical Modeling. We and the Catholic University, for example, we have they are part of one of our bigger projects, Ocean IA, that we are going to be presenting later this week. The Universidad de Valparaíso, the Universidad Técnica Federico Santa María, the Millennium Institute of Fundamentals of Data, Universidad Adolfo Ibáñez, Universidad de la Frontera, la Católica de Valparaíso, Concepción, Andrés Bello, Diego Portales, la Austral de Chile, and the INIA, which is the Chilean Institute for Research on Agriculture. There, by the way, now that I see this slide, there are many other institutions that we can, let's say, point out here also, like ALMA, the radio telescope, that is missing from here, but we have this also very important network. So, and this is a call for interested researchers, by the way, and all of you that are interested in developing these opportunities. We have, let's say, thanks to these collaboration activities, we have live connections and live counterparts in all of them. So, and therefore the goals of the network are, of course, to promote this French-Chilean scientific cooperation, to create a community of researchers who share interest and have means and to support this community. Then it's very important to strengthen existing collaborations within Inria and Chile, and of course to identify new opportunities where we can develop projects and all of that. I think that here I can give back the mic to Claire and Cecile, and by the way, I can keep presenting. Just let me know if you want the next slide and all of that. Okay, thanks.
Many thanks, Luis. Buenos días a todos. Bonjour à tous. So I am Claire. I collaborate with Inria Chile director and team from Inria headquarters from the International Relations Department. And we are currently building the content of this network together. It is a new initiative, but based on existing activity of Inria Chile. And according to the objectives Luis has explained, we have in mind several actions inside this network. The first one will be to continue organizing networking activities through scientific events like this Inria Chile Scientific Days. And hopefully in the future, we hope to hold face-to-face events also. A second action will be to share more and more useful information. Inria Chile website and social networks already presents many information. For example, to promote the funding programs for Franco-Chilean project. You may know, for example, Inria program for associate teams. Cécile mentioned it on the introduction. Or also external program like ECOS South Chile, ECOS Sud Chile, supported both by French Ministry for Research and ANID. By the way, tomorrow we'll have a presentation from the French Ministry presenting, among others, the ECOS program. And there are also another successful cooperation programs, STIC, Math and Climate am Sud, which gathers many French and South American partners, among them ANID and Inria. And the third action will be scientific matchmaking. And that means if you are searching for data, partners, researchers to collaborate with, or talents as PhD, postdoctoral fellows, students, thanks to Inria Chile knowledge of both Chilean and French ecosystems, and thanks to its strong links with Inria in France, we will realize this scientific matchmaking. Next slide, please. Thanks. The French ecosystem of research innovation will be presented in details tomorrow by the French Ministry of Research. But to make a focus on Inria ecosystem, at Inria we have 9 research centers, which have close partnerships with French university. You may recognize some name on the map of very known universities. So this gives you many opportunities with France. And as detailed earlier, many research topics in computer science and applied mathematics are represented. Next slide, please. So today we are officially launching this network, and it is important to say that it is built for researchers in a bottom-up approach. So it is very important for us to know the needs of the researchers already involved in this network, for example, the principal investigators of the associate team, but also of the researchers willing to be involved in the future in this network. So do not hesitate to contact us to share your insight about this network. For example, are you interested in another scientific event next year, a webinar to present funding programs, or a newsletter to gather information from both Chilean and French sides? So we are our 2 main points of contact, Luis as scientific director of Inria Chile, and me from the headquarters of Inria in France. With also the other team will be able to answer your questions or needs following this presentation. Thank you.
Okay, so thank you very much, Claire and Luis. And I hope that we have given you the will for those that are not already involved, and even more the will for those already involved to work with us, so we can really have even more activities than what we currently do, which is already very rich. And thank you very much.
Awesome.
So
Thanks.
yeah, we can say goodbye. We don't know how to say we are done.
Thank you. Thank you for everything.
Thank you very much, Daniel. Thank you.
Well, thank you. Thank you to all the participants in this activity. We want to thank you again for your participation in this first instance. Cécile Vigouroux, Director of International Relations, Inria, and Claire Sanleger, Head of Americas in the Department of International Relations at Inria, and also Luis Martí, Science Director at Inria Chile. Thank you all. Thank you very much. Well, after this excellent presentation on the Inria French-Chilean network of research, and this is very important for us, we want to continue to our first keynote. Mark Schunauer. Mark Schunauer is Principal Senior Researcher in Inria, who joined in 2001 after 20 years with Centre National de la Recherche Scientifique at Centre de Mathématiques Appliquées of École Polytechnique. Well, he's going to talk about a very important topic, hybridization of the future of AI. During the presentation, we will be receiving questions through the chat. This is very important. You can send every question that you have through our chat. There are two chats, one general and one specific for questions. Please use the question chat. This is very key. Welcome, Mark, to the Journées Scientifiques Inria Chile 2022. The floor is yours.
Good morning, good afternoon, everybody. I am Marc Chenauer. I am researcher at Inria Saclay in the Tau team, working in optimization and machine learning. I'm also Deputy Research Director of Inria regarding AI. And it's my pleasure to be here at the first Scientific Days of Inria Chile. So I'm going to talk to you about hybridization as the future of AI. And more precisely, because it's almost commonly admitted that hybridization is kind of future of AI, but arguing why I think hybridization is also the future of public research in AI, more importantly. So I will first set up the scene and give you the context and some reasons why I think hybridization is the only way to go for AI research. Then I will list a few of Inria related projects. And finally, describe a few use cases where I think hybridization of machine learning with symbolic AI, formal method, applied math is ongoing very dynamically. And that's it. So let's go. Well, it all starts with Alan Turing regarding AI. This is not really a scoop. In his paper, Can Machines Think, in 1950, Alan Turing described what is seen now as AI as a tool. By contrast, the Dartmouth workshop, who first coined the term artificial intelligence, AI, argued that intelligence can be viewed as a sequence of logical operations. And if this is the case, then some computer, powerful enough computer, could reproduce the reasoning and the functioning of the human brain. And AI was seen more as a goal there. And ever since, so this in the late 50s, there is this symbolic debate with ups and downs for one or the other. It started with the let's say the advent of the logic AI, symbolic AI. But then there was what is called now AI winters, that is periods where research didn't deliver what was promised. And so research in AI in general and in symbolic AI in particular was all the funding was cut. And more recently, it was coming of age of some symbolic AI or numerical AI with the deep learning advent. Since the 2010, 2012, deep learning has really outperformed any other technique at this point in time, starting with image recognition and natural language processing, and now gradually invading all of science, which is what I'm going to talk about. But the success are really impressive, and there are many domains where real advances were possible thanks to deep learning. However, there are also some hints that maybe deep learning starts to hit a glass ceiling, not because of its power, but because this power comes also with some lack of trustworthiness. So what is trustworthiness? Well, trustworthiness is not really well-defined concept, but under the word of trustworthiness, one really groups transparency, explainability, and I will come back rapidly on this, but basically if some deep learning tool refuses your loan, you're entitled to know why it was refused, or even better, what you could do maybe to have it accepted. It also goes with a lack for deep learning, a lack of robustness, and the absence of certification that would allow to use deep learning models within critical systems, for instance, and lack of privacy. There have been many examples of attacks against robustness with these famous adversarial examples. You all know that you can modify a few pixels of an image and then have the classification be completely changed. There is also, you can also maybe sometimes ask the system, by just presenting some examples, if this or that example was used in the training set, for instance, and then recover some private information, even if they were very well hidden. There is also high concerns regarding biases and the lack of fairness of data-based models, and how could this be mitigated or completely suppressed, and how could AI be used for the social good. And finally, there are concerns, increasing concerns about the sustainability of deep learning. You've all heard about these large language models, that have billions of weights to be learned, and there are learns of on millions of examples from a huge corpus, like the whole of Wikipedia and the like. But it takes millions of dollars of energy, and it produces a large amount of CO2. And so this is not sustainable if you continue the increase of the current tendency on having larger and larger models. So to fight this, there have been some calls for actions, and in particular actions using symbolic AI. Excuse me. So, but hybridization is not only concerned with symbolic AI. Let's place ourselves in the perspective of AI use as a tool, which it is also becoming in many domains, that we will see later. Something also has changed compared to other disciplines, I would say, in that now we have these new players in the game, the huge tech giants, GAFAMs, BATX, and others. And they also invest in basic research, and not only in directly applicable research for their own needs. They do both, of course, but in basic research, they invest more than any public institution can afford. And they invest both in material resources. They have thousands of GPUs, for instance, but also human resources. And that's the brain drain used to be only from, let's say, French academia to US or other countries, because our researchers are not well paid, as you all know. But now they get even better paid in the GAFAM and Scientifiques, and so there are even more incentives for them to leave academia and go there. And the usual argument that we used to have was that, yes, in public research, you are not that well paid, but you have a freedom of research. And unfortunately, or fortunately for the people working there, this is not true anymore, because some researchers from my own team have left to these giant tech research labs, and they say they are doing exactly the same kind of research with the same freedom. Whether this will last is another story, but at least at the moment, this is not an incentive anymore. And this has led to this, what I call irrational exuberance. The last NIPS or NeurIFS, now it's called edition, one of the best well-known conferences in machine learning and in neural networks, has more than 9,000 submissions. So can you imagine that? And it has more than 15,000 attendees. So it is really going big. But what the GAFAM address are, let's say, around AI and not only deep learning, of course, they also invest in some other related topics, but they do not have the same focus than public research. Public research in all countries, but especially in France, within, for instance, with CNRS and university, excuse me, covers all scientific domains. And this, of course, includes mathematics, physics, chemistry, biology, but also goes to the social sciences, like history, sociology, and the like. And this is something that the GAFAM, at the moment at least, do not possess. And the other argument is that, yes, AI as a tool is becoming ubiquitous. And this is why I claim that the future of public research lies in hybridization of AI, public research in AI, like in hybridization of AI. Okay, now let's look at some projects that are going at Inria in this direction. So these are big projects, but of course, later I will describe just actions, use cases of hybridization that do not have to be related to big projects. But Inria is related in big projects. And one of them, for instance, is HiAI. Yes, I hope you like the name too. Hybrid approaches for interpretable AI. So it's what is called an Inria challenge, meaning that it's several Inria teams. You have got the names here, from Lakodam to Tau, are grouped together to address a challenge which is too big for a single team. And the other challenge is that having hybrid meaning symbolic and semi-symbolic approaches to improve interpretability and explainability of AI. So the idea is here. You have some machine learning system that's been learning from data thanks to a system designer, and will be interacting with the user, which is the basic framework of all machine learning systems. And so the idea is that to allow the user to put some constraints on the system based on his own knowledge, that's some symbolic knowledge, and to get in return explanation, and in particular, causal explanation. And I will come back to causality later. But also it should allow the designer to better debug the machine learning system, to which the not only explainability, but also transparency and robustness, because if you can debug, and in particular, using causality in debugging. So that's one of the main Inria challenge in AI. Now there is also a European challenge called Trust AI, Trust for transparent, reliable, and unbiased smart tool for AI. And here, the figure is a little bit different, but basic ideas are the same, except that here, the project goes not only to human interaction with the system, but also using cognition models to better understand what's going on and guide this search and the learning algorithm to more interpretable AI. And then we give an example of what is going on there. And, well, finally, no, but this is another of the big networks I am personally involved in, which is Taylor. Taylor is Foundation for Trustworthy AI, integrating learning, optimization, and reasoning. So this is also some kind of hybrid project, but hybrid AI. It's a network of excellence, meaning it is not funding research, but it is funding networking between researchers towards some given goal, which is trustworthy AI. And so the idea is you have trustworthiness, which is one of the main work packages of the network, and then you have the scientific work packages, or the unification of AI paradigm representations between symbolic and sub-symbolic. How do you use AI to decide and learn how to act? So this is related more to reinforcement learning and robotics. And then reasoning and learning in social context. It involves, let's say, AI systems interactions, but also interaction with human users, as we could see. And last but not least, the auto AI aims at making AI accessible to non-AI specialists. AI and not only machine learning, but in particular machine learning require that what is called now data scientists in general. And the idea is to allow more people to at least start using AI in their own company without the need to hire very expensive data scientists. Okay, now we're going to survey a few use cases of hybridization of machine learning, because deep learning and machine learning are today the most prominent parts of AI, with symbolic AI, formal methods, and applied math, as described. Okay, so I already described the AI project, and in Taylor project, you've already seen this. One big issue with today machine learning is the explainability. In particular, with big the huge models that came out with, as I said already, billions of weights. There's no way you can understand why it took this or that decision or recommended this or that action. So there are many broad ways to approach to hybridize symbolic and deep learning. Well, for instance, you know that deep learning performs end-to-end learning from pixels to identification to decision, whatever. Whereas there had been decades of research in image processing that came up with features that we can call here symbolic features, like trying to identify the contours, the different objects, and so forth. And so you can add this, for instance, as input to the deep learning. This was for image processing, but you can also do more similar things in natural language processing by adding constraints in the form of templates or paraphrasing these two sentences are exactly the same meaning, and so forth. Now, you know, deep learning also learns some intermediate latent representation of what it is learning. And so maybe this is the space where you should be and try to identify features there. So you do some feature selection, but in the latent representation, and then you need some human expertise to eventually identify these features or just validate them. That's the more general issue is how can you represent, and usually this is symbolic, and learn and use domain knowledge to put some constraints on learning. But another completely different approach is the post hoc explainable AI. You have a model, you don't really know how it works, but you are able to locally around some decision, some image recognition or some translation, to find a symbolic model that is explainable and that will mimic the huge model, at least locally. Now you can, of course, expect or try to find to extend this local treatment to more global ones. And the question then is, and that's very often asked, how much are you willing to trade? How much accuracy are you willing to trade for explainability? Last but not least, I will describe a little bit more of causal modeling, because this is something that's a difficult issue that has been maybe a bit neglected in the past. So some examples from the III project, but also from the Taylor project, because there is some overlap. Remember, III started before Taylor. So these LLMs, large language models, sometimes called foundational model or foundation models, in particular by a recent Stanford report, they are now ubiquitous in natural language application. All the recent big success are based on BERT, GPT, and the like. So the idea that you learn a model, which is rather general, is not trained to any specific task. It learns representation, or what is called maybe word embeddings, from huge corpus of text, of documents. And then when you have a specific task to perform, you start with this pre-trained model and learn a fine-tuned model. These are the large models that cost so much energy and money to train. And that's where maybe public research is behind at the moment. So within an AI, you have, in the PhD of Georgios Avrakis, you have two different approaches. First, retrofitting was proposed a few years back as a way to handle, let's say, equivalencies from some semantic lexicon. And so this was proposed in a static, for static context. But now the idea in this work is to use the same kind of, to adapt the retrofitting to contextual embeddings like the one for these huge models, thanks to the attention mechanism and the transformers. Another ongoing work is that to solve the target sense verification. For instance, the usual example is alphabet. You have the word alphabet in a sentence, but alphabet can be the letters of the alphabet, but can also be the mother company owning Google and all others. And so you have to solve this ambiguity. And the proposed approach here is to use analogy. So you use BERT to represent the components of the analogy, that is, and you transform the target sense verification into an analogy solving problems like to model the relation. So is to and as, for instance, context is to definition as hypernyms are to definitions. And if you can, using this classifier you've learned, if you can find this is a valid analogy, then it means that you've solved the target sense verification. You verify the sense of this. Okay, now there have been some earlier work in the WeMix teams where they do use some symbolic features that they extract from the text. That's what I described for images, but it's done also here for text. So they do use symbolic features that they use as input also to deep learning models. And this is also based in some neural network setting. And basically, this is of great help to first detect hate speeches, or bullying. That is also important in particular among teenagers, well, not only. And also to analyze debates, political debates, for instance. And I would be glad to see what they could say about recent political debates in France, but this was earlier. So they use some argument mining, but not only for political debates, but for clinical trials. So you can really find the arguments that explain why the doctor thinks that this is the cause of the illness. This makes a very good transition to causal modeling. What is this about? Well, current machine learning tools, and in particular deep learning, in fact learn correlation. For instance, there is a clear correlation between umbrellas that you see throughout the window and the fact that it rains. But of course, rains causes umbrella to come out, but even if everybody opens its umbrella, it will not make rains fall. And so the idea is, if you want to be able to control, then you should be able to know what intervention will do. And this is based on causality, not on correlation. So basically, variable xi causes variable xj if everything else being equal. When you change xi, it changes xj. The royal road to causal discovery is randomized control experiments, and that's what is done every day for medical treatment, for instance. You have two populations, sample with the same distribution, and to one of them you give the treatment you want to test, and to the other one you give a placebo, and then you look at the results a few days, weeks, months, years later. But it's not always doable. For instance, we have only one planet, so there's no way we can do some randomized control experiment with climate, for instance. It can be unethical. You cannot ask some people to start smoking just to find out what causes lung cancer and so forth. So can you infer the causal graph from data? It's doable for pairs, and it's been demonstrated by some challenges, the pair causal challenges. But it becomes intractable if you want to do the full graph and you have lots of variables. Of course, you can make simplifying hypotheses, but not so well satisfied. And so this is where you might want to learn the complete graph by mixing symbolic ideas here from causal learning and from causality, as popularized by Judy Apple, and he got the Turing Prize for this, and deep neural network and borrowing ideas from the GAN, Generative Adversarial Network, excuse me. So basically, you generate fake examples by predicting one variables by all others, or by as few others as possible. And you use the GAN idea of a discriminator that tries to recognize between fake and real examples, while the fake part tries to fool the discriminator. So this has been applied in Devian Kalinatan PhD in Tao team. And it's been applied in many domains of social and human sciences, like there's a correlation between quality of life at work and the wealth of the company. We would like to know if there is a causal effect between these two variables and in which direction. Also, you want to be able to tell people that are looking for a job why they didn't get the job, and more importantly, which kind of training they should follow to get a better job, to get the job they want. And also with nutrition facts, nutrition data, what causes, for instance, type 2 diabetes. And within III, we aim at predicting the repetitive action, that's like Odam work with frequent item set, and what are the triggers of this repetitive action to improve the help the user can get. Okay, now we go to formal methods. And there's a huge number of worldwide known teams in France regarding formal methods, in particular at Inria. So there are, I will give an idea of the next slide, a use case about how you might be, what could be a path to formal proofs of neural network. But there is also the reverse, that is, machine learning can also help formal proofs to validate some proofs. Another path, another aspect of certification and validation is that of adversarial examples that I already discussed at the beginning. You modify a few pixels, or you put a few stickers on some road sign, and the classification is completely changed. So there are methods from robust optimization that are being applied for this. Again, methods that were used in numerical simulation are ported to the certification of neural nets. But you can also use abstract interpretation techniques to prove that there will be no adversarial examples in this or that part of the space. There are issues with privacy, as mentioned, and studies about how to use differential privacy for neural networks. That is, you blur the example and you blur the output. Interestingly, natural idea would be to use GANs, generative adversarial networks, from a large database, for instance, of medical data. And then with GANs, you can generate completely artificial data that follow the same distribution than your database. Unfortunately, it seems that it might not be enough to guarantee complete anonymization, because you might be able to recover the fact that this or that real example was used to train a GAN. Excuse me. And finally, tools from topological persistence and topological homology are being used in topological data analysis, for instance, with the data shape team in Saclay, as building up additional features that you can use to handle your data, and it improves the performance of the deep network. Now, very briefly, an example of formal verification of neural networks. That's a PhD of Julien Girard in Tao team last year. And one of the main issues here that they want to cope with is there is no formal definition, for instance, of what is a pedestrian. You want to avoid pedestrians, but then before avoiding them, you should be able to recognize them. And if you want to use formal tools to prove that you recognize all pedestrians, you should be able to do a formal specification of pedestrian, and this does not exist. So the idea used here is to at least recognize all pedestrians coming from a simulator. So here you have a simulator that takes as input some parameters to build the scenery where your system will evolve. And here it builds an image, and this is the learned system that from the image issues, here is a pedestrian, or no, there's no pedestrian, for instance. And so the idea is to split this in two by first reconstructing the parameters of the simulators, and they contain the fact that there is a pedestrian or not, even though we don't know how this is described. And these parameters then are used to generate the output. And you can here prove both separately, both this first part and the second part. And there's some proof that, yes, you will never miss a pedestrian, but this is at the moment for small networks. And then, if you consider the Rayleigh transfer function, you know, which is 0 and then identity for X positive and 0 for X negative, you can consider that it transforms your space into many subspaces, which were called facets. And on each of these facets, then the problem is very simply linear, because you have only either 0 or some linear transformation. But of course, this is NP-complete, and you should find tricks to count the facets and then count the ones that are important and so forth. So this has been done in the DISCO framework. And now we come to the last part, which is about applied mathematics, where again we have many, many teams in France and at Inria that have world-class reputation. If we start with control, then control amounts in the machine learning community, control is done with reinforcement learning techniques. And for instance, I engage you to look at Peter Bill's helicopter aerobatics demonstration, where this is a very, very difficult problem, and he solved this by using machine learning to online adapt the parameters that are used in the deterministic controller, classical deterministic controller, because you need to take into account the fact that there are gusts of wind, there are temperature variation when you go up and down, and so forth. So it does this with machine learning. You have ideas to identify the nonlinear dynamical systems that was proposed, for instance, by Steve Brunton, using sparse learning to learn the system from observations, and then also Josh Bongard and Harold Lipson, genetic programming. And I will show you a brief example of how genetic programming can, in some context, generate explainable reinforcement learning. And so reinforcement learning works like this. You have some agent in an environment. The agent observes some state. Based on the state and based on policy, here represented as a deep network, it takes some action. It gets or not a reward, and then this is iterated. And so the idea is to replace this deep neural network by some analytic expression as simple as possible, which is what genetic programming does. And it works pretty well in simple environments. Next slide. It works not so well in complex environment because you can get trapped in local extrema. However, there are some tricks that can help you to improve the performance without losing on complexity, which is a proxy for interpretability. So this is an example of what Mathieu Ravido did in the Tau team with Alessandro Leiter. So basically, you obtain this as a controller, and you can explain that this addresses the fact that you want the spaceship to be at the center here, and you want it to stop the lateral motors when you are at the center, and same for the vertical control. You want to slow down when you come to the ground. Okay, so this was a good situation. Now there are many that was control. Now for numerical simulation, you also have many approaches. The, let's say, conceptually easiest to understand is when you use machine learning, and in particular deep network, as a surrogate model where you predict. You have a huge database of the results of numerical simulation, and you use deep learning to learn these results directly. So it's been called surrogate models for decades in numerical simulation, though it was not made by deep network. A deep network of very, very good tools for regression. For instance, in climate models, where you have lots of cells around the Earth, in each cell you have to solve a complex partial differential equation system, and you can learn this system and gain an impressive factor in terms of computational cost. I told you already about identification. You can, when you get a model that first maybe is not precise at all because there were too many simplifications compared to the direct model, or you have to simplify it even more because it's too costly and it's all the family of reduced order models, you can use machine learning to learn a corrector of this numerical model. You can, of course, easily solve inverse problem, the same way you solve direct problem here, by using the regression power of neural networks. And you can do meshless simulation in high dimension, learning both the physical model and its solution. And there are also lots of yet unveiled applications using transfer learning, domain adaptation. A very nice example of just a surrogate approach that's very neat by Stéphane Cotin and the Mimesis team in Nancy. The idea is you want to calibrate, to use numerical simulation to follow a tumor here in the human liver during a surgery. You might want to remove it. The problem is that as soon as you touch the liver, it deforms, it gets deformed, and you cannot know anymore where the tumor is, even though you knew perfectly at the beginning by offline experiments. And the PDAs are very complex, and it takes ages to simulate, given the effort the forces you apply on the liver, where the tumor is. And so the idea was to learn a deep network from masses of simulations, even if they take long. This is offline, and then online you gain a huge factor again here. And the beauty of the thing is that Stéphane Cotin used such architecture, which has been identified in image processing to identify to do segmentation, but it was also known in the numerical simulation community to go from fine grain to coarse grain and to accelerate the simulation. Last but not least, this is the PhD of Balthazar Donon in the Tau team. The problem is that the simulation of power grid, you have some production and consumption and some characteristics of light. So this is a very simplified power grid. And you want to predict what will be the voltage and the power flow to avoid that too much power goes into a line that will start heating and could burn. And the idea is that rather than being based on many simulation, like in the previous example, you directly minimize on each of these segments the violation of Kirchhoff laws. And you use for that graph neural network, which are neural network, deep networks on graphs. That is, here you have your network, you do some encoding to go in a richer space, and then you do some steps of message passing, like in message passing algorithm of statistical physics, and you get the output after decoding. And the interesting thing is that all these arrows here represent the same neural network. And so you learn the same neural network and you apply it at different nodes and edges, and it can generalize to many other topology of the graph, and something that is very, very important in the distribution networks. Last but not least, sorry, this is the last one, using ideas from sensitivity analysis for hyperparameter optimization of neural nets. I already insisted that there's a lack of data scientists, or people might not want to hire data scientists, so this is a way to automatically find the parameters of when you design a neural network. Before learning it, you have to design it. And basically, some ideas of sensitivity analysis, again, that exist for ages, have been applied by Paul Novello at Centre de Mathématiques Appliquées de l'École Polytechnique, under the direction of Paulo Congedo. So you find the relevant hyperparameters. Some of them have no influence on the result, and you find default values for this in influence. Okay, we're almost done. What are the take-home messages? Well, I hope I've been clear. Don't put all your eggs in one basket. If you are a research institution, diversity is critical. of course, a single researcher should concentrate on very few domains, but institutions should really invest in all domains and not neglect even domains that maybe look a bit outdated, but see at the comeback of symbolic AI, for instance. And then disseminate AI tools. We've seen that it can be useful in many domains: biology, chemistry, so human and social science. And we also discussed that there is a lack of data scientists because of the explosion of AI and because of the brain drain. Sorry. So auto AI might become really essential in the near future. I've said little about sustainability, except for some big foundational models, about fairness, but the problem is not like explainability, that there are no definition of fairness, but there are too many and they are contradictory. Privacy still needs a lot of work, and ethics needs at least a lot of discussion, especially in those days of war, where lethal autonomous weapons make a big comeback. They are not all autonomous, but there are some lethal autonomous weapons, and probably we should try to, well, not probably, we should try to ban them, like have been banned nuclear and chemical and biological weapons. Thank you.
Thank you, Mark, for this very interesting presentation, a very good keynote. Remember, we have two chat rooms, one general chat and also specific for questions. So it's time to open, in fact, the Q&A session. And we have a lot of interactions here. Hi, Mark. I greet you this time. We have a very much questions. We have at least 4 or 5. So let's begin. The first one is like a comment and also a question. It's from Patrick, and he said, very interesting presentation. There is also hybridization of ML and simulation that has much traction in HPC apps. Now, about XAI, which you describe as making ML better with the use of symbolic models. But what about the other way around? How could ML improve symbolic AI?
Can you hear me?
Yes, we can.
Okay. Oh, you took the question in the reverse order, but never mind. Because Patrick also complements his own question, saying that yes, the use of ML for formal method is part of the answer in the beginning. There are some ML techniques that use for AI. There are some AI techniques now that are used for formal methods. Yes, I mean, making ML better with the use of symbolic models and reverse, that's mostly what I've talked about. But you can improve. Well, you have a collaboration between machine learning, let's say deep learning, and symbolic models, and sometimes you cannot tell which one is helping which. I mean, it's really collaboration, and so some example I've shown, like what's done to identify the arguments in the discussion and so forth. It is the help of deep learning to get more features and then to help really decipher the conversation and identify the arguments. So I would say that basically it's really a collaboration. And you should also look at Luc Deret's work about neurosymbolic theory. So he really used both together. There's not one helping the other or vice versa. So yes, that's a good question.
Okay, Mark. Thank you for the answer. And we have more questions. We have also Veronica. Is there degradation of performance of deep learning system by introducing explanations via hybridization, you can also read it, right?
Yes. Well, yes, the answer is yes. And very often the question is, how much are you willing to trade? How much performance are you willing to trade to have good explanations? Because usually you get a decrease in performance when you want to mimic deep learner with even locally with some symbolic decision. This is why the debate is not ended. I mean, people like Yann Lequin, if I caricature what he says we don't care about explainability. We only want performance. You don't ask a doctor why his diagnosis COVID or whatever. You just want to have the proper diagnosis. You don't care if you want to jump in a plane. I mean, to fly in a plane, and they tell you, okay, this one we understand how it works, but you have 10% chance of accident, and this one we don't understand anything, but you have 0.1% accident. Which one do you choose? Well, okay, so it first depends on the domain. For critical domain, probably you prefer performance, but for more, let's say, human-oriented domain, then you need explanation. Otherwise, people will not simply accept.
Okay, thank you. Let me add something. I love the bird singing in the background. It's like a very nice soundtrack. I can hear the bird singing. It's very nice. Okay, let's go back to the questions. Astrid asked, which are the open challenge of auto AI? Can you mention some of them? Are you working on these topics?
Well, yes, it happens that I'm working on this topic. Well, or people in my team also working on this topic. So I would probably list two very important challenges for auto AI. One is multi-objective auto AI, because when you want to design some AI-based model, performance is not the only objective. I mean, we discussed this maybe before, but you might want to trade off performance and explainability, but also something I did not mention that much. You might want to trade off performance and consumption, energy consumption, or CO2 emission. So really, it is something that is very little visited, this multi-objective auto AI. And the other one would be probably regarding lifelong learning. I mean, systems that go what we call sometimes in the wild, and then probably they have to adjust their own parameters, but to continuously learn from new facts, because of course the context change. And so this is something also that needs to be an avenue for research.
Okay, Mark, thank you. Thank you for both your keynote and also the interaction session. Thank you so much. Okay, let's continue. After this presentation on artificial intelligence and this hybridization, we want to continue developing this topic, but this time learning about projects developed in the framework of Inria Chile and developed jointly between French and Chilean researchers. We will continue to the first scientific session, AI and machine learning. Now, we present the first scientific session on AI and machine learning. During this presentation, we will be receiving questions through the chat. There are two chats. Let's say this again. One general and one specific for questions. Please use the question chat. The chair of this session will be Luis Martí. As we mentioned earlier today, Luis Martí is the Director of Science at Inria Chile and has a PhD in applied artificial intelligence. He's an expert on neural networks and evolutionary computing. Luis will be sharing this first scientific session. Thank you, Luis, for joining us today.
Hi, Daniel. Can you hear me?
Okay. I can hear you very well. Yeah.
That's awesome. Well, it's a tour de force to start by saying hi to Mark. He's a very dear, how can I say, it's like a father to me at this point. Only that I am an older son. So this session, as Daniel was telling us, is about this set of projects that we have where Inria Chile takes part of them. And we don't have a lot of time, so I will just introduce the first project form. And I don't know whom do we have, but I think that, do we have Cristobal or his video?
Well, thank you very much for the invitation. I'm really glad to give this talk. This is basically a summary of the work that we have been doing in the associate team forum in collaboration with the Sierra Lab from Inria in Paris. And yeah, before I start with the actual scientific content, let me say a little bit about the group. So the group is split between researchers from France and Chile. Researchers in France are mostly, as I said, from the Sierra team from Inria. Chilean faculty are split between the Catholic University of Chile, UAI, and also some collaborations from Inria Chile. And we have a number of students here. I'm just showing some of them. Actually, there's more students, but there's just enough room on the screen. And in terms of what we have been doing, well, first of all, this associate team was originally planned to work from 2020 to 2022, but of course the COVID-19 emergency postponed most of the activities. So we're actually starting this year in terms of the activities, although we're still ongoing with the research, and we have quite a bit of results already. So at least as far as the research has gone, I can say that things have been going on as expected. We have graduated a number of master's students, PhD students. We have papers published. And, I guess what is good about postponing the span of the project is that we'll be able to even go further with the research. I don't mention it here, but we also, since these traveling activities were canceled, we were able to even establish some collaboration through online meetings and reading groups mostly. The research lines of the group are focused mostly on optimization techniques for machine learning, and those take different flavors. First of all, I will mention a little bit about our work on inferring linear orderings, in particular for seriation type problems. Then I will briefly say a little bit about our project on fast gradient methods for stochastic optimization and machine learning problems. And finally, I will also give a very brief introduction into our work on differentially private stochastic optimization. So as you can see, there's different flavors of problems. The kind of the span of the project is pretty broad, but to say in short, we're interested in sort of the crossover of optimization and machine learning. Yeah, let me advertise some upcoming events. We're very glad to be hosting or be part of the organization of Roberto Combinetti's Sected BERT conference, which is coming up in January. And there's not much information out there, but we'll soon be releasing that publicly. And in 2024, we'll be doing a closing workshop, hopefully in Chile, with all the researchers. Okay, so let me start with the first project that I mentioned, seriation. And for this, I will take as an inspiration a problem which is encountered in genomics. So the idea is when you have long sequences of DNA, the way they are extracted, they usually come from obtaining sort of random segments, but small from this very long sequence. And the goal here is to reconstruct the whole sequence of, just from these short subsequences. And the question is how you merge these pieces of information to reconstruct the whole ordering. Typical applications of this DNA sequencing are assuming that the kind of sequence is linear, so you have this kind of object, but there's certain types of virus and other biological objects which have rather a circular structure instead. And in that case, what you have is that your DNA sequence sort of wraps around, but you still have the same problem. Now you want to reconstruct this whole sort of circular sequence just from small segments obtained from the DNA sequence. So in more abstract terms, what we see here is that you have some kind of linear ordering of certain data, and you obtain, for each of these pieces of data, some kind of partial information about how these different objects relate to each other. So in the case of this DNA sequence, the sort of similarity measure used for the different segments corresponds to how much overlap do they have in terms of the how much these two elements would overlap in terms of having a coincidence in terms of certain characters. Okay, so given any pair of elements, you would say that their similarity is just based in terms of the sort of the maximal matching between subsequences that you can overlap between these two. And you just have that information for any pair of these segments, and the idea is to infer from only that sort of similarity measure what's the overall structure. This kind of problem have been encountered in different settings, and more classically, as I said, what it has been studied, which is called the linear seriation problem, corresponds to sort of a similarity measure. Here you can see this sort of color heat map in terms of similarity, where diagonal elements have the highest similarity, and then as you move away from the diagonal, this similarity measure kind of drops. And in the seriation problem, what you will see is some kind of permutation of this matrix, and the idea is to reconstruct the original structure, which has this shape. And if you have a matrix of n by n, the optimal algorithm for this linear Robinson case has complexity, which is order n squared. And this is very nice because basically n squared is the number of coefficients we have here. So it's as fast as it can be. What we focus in our work is what I said before, is a case when you're not anymore looking for a linear structure, but rather a circular one. And then what you can see in terms of, because of this sort of periodicity of the sequence, you no longer see this decreasing pattern anymore. What you see is more like a unimodal pattern. So when moving away from the diagonal, the dissimilarity measure decreases, but then at some point starts increasing again, and then it sort of wraps around from the other side. This problem turns out to be more difficult. Just even defining what it means to be circular Robinson is actually not something that is fully agreed on the literature. There's not a complete agreement. And also there's the issue that existing algorithms are not as fast as in the linear case. So prior to our work, the best existing algorithm had complexity n cubed. What we did in our work, and let me say here, this is the kind of shape you will see when you sort of randomly permute a circular Robinson matrix, and the goal in this problem is to reconstruct the underlying order. And in this work, that was actually my student Santiago Armstrong's thesis, and it was done in collaboration with Carlos Singlong, and it's been published in the SciMods journal. What we do is we propose a definition of what we call the strict circular seriation, which is related to this sort of unimodal pattern that I described, and the strict comes from this sort of pattern being strictly increasing and decreasing. As I said, in the literature, there is not a complete agreement about what the natural definition of circular seriation is, but we think this is, at least as far as the theory is concerned, is quite useful because we're able to analyze it and find an algorithm that works in order n squared, and therefore it is optimal. And finally, we also relate this to some kind of generative model. So instead of just using this definition of solving the problem, we think about situations where you sort of sample points based on a certain similarity measure, and we answer the question of how many samples are sufficient to recover the original ordering. That's the first part, as I said, linear circular seriation. The second line of work is based on complementary composite optimization. So this is more related to kind of standard machine learning models, but here we'll present in a very high level and sort of abstract way what we're interested in. So suppose that you have a certain problem where you're interested, for instance, in minimizing a loss function. This would correspond, for instance, let's say some kind of classification or regression error for a given loss function that you determine based on data or some underlying distribution. We will assume that this function f is convex, is smooth, and more interesting for machine learning applications. You're not able to evaluate it exactly, but you only have access to an approximation of it or based on a first-order stochastic oracle. So given any point, instead of being able to compute the exact gradient, you get an estimate which has a certain amount of variance. So that's as far as the loss function is concerned. Typical for machine learning applications is using some kind of regularizer. So the second term here, h of x, would correspond to a regularizer, which is assumed to be strongly convex, and we will make no other assumptions. So this can be potentially an unbounded function. And one case that could be interesting is, for instance, using the negative entropy, which is bounded, but will have infinite Lipschitz constant. And yeah, and we consider any sort of closed convex set X. In prior work that worked with Yelena de Conicolas, we were able to understand how to solve with the optimal rates this problem in the case where your stochastic order, first order oracle is exact, when the variance is 0. So you just have exact access to the gradient of f, and h is just given to you. And we're basically showing rates that have linear convergence. So the sort of cost in terms of the target accuracy epsilon is only logarithm of 1 over epsilon. And more recent work done in this project in collaboration with Alejandro del Promont and my PhD student Clement Lesan, we're able to show that when now the stochastic oracle may have positive variance, you get a very similar result. You still have this logarithmic dependence on 1 over epsilon, but the stochasticity of the oracle leads to another term that depends on the variance. And let me say the second term, sigma squared over mu epsilon, is indeed optimal for stochastic optimization. This first term instead is not quite optimal because of lacking this square root, but we're still, this is ongoing work, so we expect to be able to match the exact optimal complexity in the future. Okay, and finally, I will talk a little bit about work that we have done in the area of differential privacy. And I know that this might not be entirely familiar for everybody, so I would like to first do an introduction. First of all, maybe it goes without saying, but nowadays protecting sensitive data in all sort of data analysis procedure is a major concern. Unfortunately, naive methods such as anonymizing data are quite ineffective. And there's a number of examples that are now well known. The point is, maybe you're releasing some kind of anonymized data set, for instance, what happened with the Netflix challenge for making this contest about recommendation systems. There was an anonymized data set containing, I will describe this example right next. But the point is that you can combine publicly available data with anonymized data and then just do this, cross this data and figure out more information about the private individuals than you did know before from the public data set. So yeah, going to this Netflix example, what we have here is for the Netflix challenge, Netflix released a whole data set of user scores for movies, but this data, of course, didn't have any names. It was completely anonymized. But on the other hand, there was this publicly available data set where people were actually providing their names and where they were giving partial score to some of the movies. And then just mixing these pieces of information, it's easy, and it turns out to be effective in practice, to be able to re-identify the users just based on pattern matching in terms of the scores. And just as in this example showing that anonymization is not effective, there's a number of examples where you can see that we have to be very careful when it comes down to protecting private data. And fortunately, by now there's a well-established definition of what it means to protect private data, which is called differential privacy. So the idea of differential privacy is based on this thought experiment where you consider your whole training data set being augmented by adding another user, which could be of two types, okay? So basically we want to understand how our algorithm or how sensitive is going to be our algorithm with respect to this choice of the last element used on the data analysis procedure. So we kind of run our algorithm in parallel on these two data sets when using either the blue element or the red element. You see our results, and what we expect to see is that the outcomes of this algorithm in these two situations are pretty similar. So the fact that I use the blue element or the red element is almost indistinguishable. And more quantitatively, what you can say is that this procedure will be epsilon delta differentially private if whenever you look at any sort of event in the outcome space, the probability of it happening under dataset S is almost the same as under dataset S prime, where dataset S is the one containing the blue element and the red one is containing the red element. Okay, and in words, this just means that except for unlikely outcomes quantified by this delta parameter, the likelihood ratio between both outcomes is close to 1. So one of the issues when using this sort of definition is that typically leads to error rates which scale with the dimension of the problem. So then, for instance, if you have a very large number of features in your models, that number of features is going to affect the performance of these private algorithms. And in fact, the risk function would behave in this formal sort of way. So you will have this sort of non-private rate 1 over root n, which we know from, say, central limit theorem. And then there's this extra term associated to the cost of privacy. And the fact that for high dimensional problems, you get, very high error rates is what is known as the curse of dimensionality in differential privacy. And in this case specifically is for stochastic convex optimization. What we did in our work with Rahip Vasili and Upamanandi is showing that in some situations, and I will explain in a moment which situations are those, the risk can be reduced to something that does not increase polynomially with respect to the dimension. It only does so logarithmically. So this is a world of difference. And this assumption that allows us to get these better rates or, slowly degrading rates with respect to the dimension is the fact that we assume a problem which has a type of geometry which is tied to the L1 norm rather than the L2 norm, which is typically used in most of the classical results. Now, this change of assumption, of course, it leads that we're not able to tackle the same family of problems. But let me say that these L1 norm or L1 geometry type of problems are very important when it comes down to sparse models. And these are quite frequently arising in statistics. And yeah, the other thing that I already said is that this bound becomes much better than the classical bound when the dimension becomes much larger than the dataset size. So with this, I would like to conclude by saying that the foam associate teams is going well. We're doing research in these 3 main lines, making progress. We're very interested in expanding our collaboration network, looking forward to hire new PhD students and postdocs, researchers for collaborative grants and so on, and even knowledge users. I believe that the kind of work we're doing has great potential for actual applications, and it would be really great to explore that. Here is the website for the associate teams. You can look it up on my website. And with that, I would like to conclude and thank you for your attention.
Well, thank you, Cristobal. I forgot to say at the beginning that we are going to be taking all the questions together at the end of the 3 presentations of this session. So keep your questions for later. This is a very interesting topic, and Cristobal, I really miss our meetings before you left for the Netherlands. So it was awesome. Let's talk about more later. Personally, I already have a couple of questions on this. The next presentation is from the house. No, it's one of the projects we have been running here in Inria in Chile related to astronomy, and it's presented by Hernán Lira. It's a fruit of a collaboration, by the way, with astronomers from and other scientists from the Universidad de Chile and the Center for Mathematical Modeling. And well, I better let Hernán present and we can discuss later. Thanks.
Thank you for the opportunity to present in this event. My name is Hernán Lira. I'm a researcher at Inria, Chile. And today I'll present how we are solving a problem in astronomy using machine learning. In particular, I talk about the study Anomaly detection for real-time identification of changing state AGNs in massive datasets done by Paula Sanchez-Saez, Luis Martí, Nayat Sanchez-P, and myself. That was recently published in the Astronomical Journal. So, as the title indicates, the goal of this work is to search for changing state AENs in massive datasets. So let's start by giving some definitions, defining the problem, and providing an overview of our approach. So an AGN stands for active galactic nuclei, which are galaxies with a supermassive black hole in their nuclei that is actively consuming material. And there are different types of AGNs. In this study in particular, we're focusing on type 1 and type 2 AGN, which is a specific classification to describe some of the AGNs. Usually, AGNs are visible within the same classification, but recently, astronomers have described a new phenomenon called changing state AGNs, which in the optical range correspond to sources that suddenly change their classification as type 1 or type 2 AGN, as well as to sources that present large changes in the flux or their broad emission lines within a timescale of months or years. So this is the important things that this type of AGN change their classification in a brief period of time in astronomical terms. So in order to understand the physical mechanism behind changing state AGNs, we need to follow these sources in real time. But for the moment, in the best of our knowledge, there's only one work by Ricci et al. In which they follow CSAGN using X-rays and optical spectroscopy. So they concluded that the observation could be explained by the interaction between the accretion flow and debris from a tidally disrupted star. So if we want to do this in a larger sample, we need techniques that allow us to search for this kind of sources in real time. So there have been some attempts to do this, but using archived data and not in real time. For instance, these studies use traditional statistical techniques to search for CSAGNs. On the right, McLeod in 2016 used the amplitude of the light curves in the G-band to select candidates. And more recently, Graham in 2020 used Bayesian blocks representation and Slepian waveless variance to select candidates using Catalina data. However, in our study, we want to test a different approach using anomaly detection techniques. The inspiration of using anomaly detection for this project comes from the work presented by Saberlak in 2020, where CSAGNs appear as outliers in the DRW parameter space. So we decided to use deep learning and anomaly detection for this project, using now data from the CTF, in particular from the data release 5, with the aim of using the method in the future with the beta routing data. So in collaboration with the Alerce broker, we can have access to the alert stream and then predict the behavior of these sources using data releases, and then check the variability in the alert stream so we can find these sources in real time. So let's move to anomaly detection, a little bit of background. So anomaly detection is a very popular technique in machine learning, and we are using in particular deep learning. So I'll briefly explain what are the techniques that we are using. So anomaly detection corresponds to the identification of rare events or observation that differ significantly from the majority of the data. So there are several types of anomaly detection techniques, but the ones that are more popular in astronomy are out of distribution anomaly detection, in which we look for sources that are unusual compared with the regular dataset. So for instance, here on the left, we have two features to describe certain phenomenon. And we can see that the normal data can be clustered in specific regions, and the anomalies are outside these clusters. Also, we use contextual anomaly detection, like the example on the right, in which instead of searching for sources that are particularly rare compared with the regular data, we are interested on sources that suddenly change their behavior. For instance, here we have a time series, a periodic signal, and suddenly we have a drastic change in the behavior of the source, and then the periodic signal is recovered. So first, I start explaining auto-distribution techniques. In this work, we are using an auto-distribution technique called isolation forest, which is an unsupervised anomaly detection method based on decision trees. So the idea is to measure how many splits we need to do to isolate a given object. Anomalies are the ones that are more easy to isolate. For example, here on the right, the anomaly is found in the first split of the decision tree. Here we have a complete example with these red and green circles. So the red circle is the anomaly, and you can see that with only one split, we can separate this object from the rest. So we can use the number of splits or the distance from the initial node to the end of the branch as an anomaly score. Now moving to contextual anomaly detection, using in this case deep learning. So first, I explain what is an autoencoder, a little bit of background. So briefly, it's a neural network architecture composed by two main neural networks, an encoder and a decoder. So the encoder learns a latent representation of a dataset by compressing the information in a vector that contains that compressed representation, and then the decoder decompresses the information and reconstruct the dataset. Variational autoencoders correspond to a modification of the more classical autoencoder architectures. So in this case, the latent representation are described by multivariate normal distribution, where each attribute or feature in the latent space is described by a latent mean and a latent variance, so which can be used to randomly sample a set of attributes. The main advantage is that bias can be used as generative models by sample different vectors for the latent space and generate different representations every time. Also, variational autoencoders force the latent space to be smooth and to cluster together subsets with similar reconstructions, and thus facilitating the detection of anomalous data. Finally, for this work in particular, we're using variational recurrent autoencoders, which is a variation of variational autoencoders that use recurrent neural networks in the encoding and in the decoding phase. So RNN is a very popular architecture for sequence-to-sequence learning and time series. Using this, we can easily deal with time series of different lengths. With variational recurrent autoencoders, we can do two types of anomaly detection. So first, we can do contextual anomaly detection, where we compute the reconstruction error of the prediction and use this error as an anomaly score. In the example of the left, the reconstruction will fail because of a high reconstruction error, and the source will be classified as anomalous. Second, we do out-of-distribution anomaly detection using the latent space as a vector of features together with the isolation forest. So on the right, we have an example from astronomy by Villar in 2021 for supernovas. Since we have all the techniques, how can we do anomaly detection for AGNs? So we're inspired by the work of Tachibana in 2020, in which they model AGN light curves using a recurrent autoencoder, allowing not only to model the curve, but also to produce forecasts. In particular, for this work, we are using a sample of AGNs from Miliquas and Rome with CTF light curves in the data release 5. We restricted the sources to point sources and with more than 2 years of data. To train the model, since we're doing anomaly detection, we created balanced samples based on physical properties in terms of luminosity and BH mass, because we want to avoid the detection of an anomaly of sources that are just super luminous or less luminous in comparison with the rest of the sample. In addition, in order to avoid any correlation between the latent space attributes and the length of the light curve, we balance the data sets by the number of epochs per light curve. To train the model, we are using mostly quasars, but to test the model, we are using more classes as indicated in the figure of the right. This is the complete neural network architecture that we implemented. We started implementing the architecture proposed by Tachibana. Then we designed a dedicated neural network architecture for our problem. Some of the modifications are variational recurrent autoencoders instead of recurrent autoencoders simply, and GRU instead of LSTM. GRU stands for getting recurrent units, and LSTM stands for long short-term memory, which are two popular recurrent neural network architectures. So here I describe the results for the training set. On the left, these are a set of random light curves we select from the 5. In black is the original light curve, and in red is the prediction. In the middle, we have the reconstruction error of the training set. So this reconstruction error is measured using the original light curves and the predictions, photometric errors and errors on the predictions. On the right, the variational recurrent autoencoder latent space attributes. In particular, we're using the mean of the latent space, is correlated with the number of detections. So the correlation is very low, which wasn't the case for the original architecture done by Tachibana. So we decided to maintain this new architecture since it is less biased to the number of detections per light curve. So once we train the model, we applied the algorithm to the full set of light curves, and we selected as anomalous the sources with very high reconstruction error with an R factor greater than 3. So here you can see some examples for regular quasars, class A and blazars. For the cases when we had a good reconstruction error, we applied an isolation forest with 2% contaminants, and we selected as anomalous the sources with a score below this threshold. So using this technique, we detect around 9,000 anomalies. And here you can see the fraction of anomaly detection by class. Blazars are used to test the quality of the method since they are intrinsically different to quasars, and they are correctly classified as anomalous. So it is a good result of the model. Several anomalies correspond to problems in the data. So problems in the photometry, like the sampling the image when we have goals that are hard to eliminate using the flags provided in the data release, and misclassify sources from the original catalog. So this can be considered, for instance, variable stores. So we used this set of candidates to search for changing state AENs, and we selected this candidate when they show evidence of flares and or an abrupt increment or decrement in the luminosity. So we visually identified 75 candidates, and these are some of the examples. So further spectroscopic follow-up is required to confirm the nature of our candidates, although 4 are already known as CSAGN candidates by Graham in 2020, and 2 have been spectroscopically confirmed already. 28 are candidates using other type of techniques in a study that is being done by Graham, that is currently in preparation. So what is going to be our work from now on? We're trying to improve our results with recent anomaly detection techniques for time series data, such as deep learning models, energy-based models, and ensemble models and architectures. So in particular, we want to improve the anomaly detection score. We want to classify classes with less samples in our dataset, discard samples with photometric errors. We also want to improve the modeling of the light curves and classify the full data release with no labels at all, with self-supervised techniques. So as a summary, we can say that real-time detection of changing state events is crucial to understand this event and to improve our knowledge of the physical mechanism behind AEN variability. Anomaly detection is a promising technique for doing this. And in particular, we used variational recurrent autoencoders architecture to model AGN light curves from the CTF data release 5. So we use the reconstruction error and the latent space attributes to search for anomalous AGN light curves. We found around 9,000 anomalies, but these anomalies are dominated by bogus candidates because of photometric issues, misclassified sources. But we were able to identify 75 promising CSAGN candidates. So further work is needed to confirm the nature of the variation, but already some of those candidates are confirmed as a changing state AENs. So of course, to conclude, anomaly detection cannot be blindly used to search for changing state AENs. So the interaction between anomaly detection algorithms with domain experts is needed in order to find reliable samples of candidates. So this was anomaly detection for real-time identification of changing state AENs in massive dataset. Thank you very much, and I look forward to your questions.
Thank you very much, Hernan. And again, we will be taking all the questions at the end, so please have them ready. And the next presentation actually is very well connected to part of a conversation that or the presentation, the keynote from Mark around these hybrid models is going to be given by Leopoldo Bertozzi from the Universidad Adolfo Ibáñez, and is about a project that regards declarative and ontology enhanced data analytics and machine learning. So the floor is yours, Leopoldo. Thanks.
Hello, everyone. I'm going to talk about the project that we are starting on ontologies and data analytics and explainable AI. My current affiliation is Universidad Adolfo Ibáñez in Chile, but I am moving in the next couple of months to the Schema Business School in Montreal, Canada. I will keep participating in the project. So this is the project. It's a stick AMSID project that we are just starting. It is on the use of ontologies in data analytics, machine learning, and explainable AI. The principal investigators behind this project are, well, myself as the international coordinator, Salima Van Bernoul of the University Paris Descartes, François Gazuet of the University of Rennes, Vanina Martinez from the University of Buenos Aires in Argentina, and Adriana Marotta from the University of the Republic de la República in Uruguay, Montevideo. Yeah, well, let me give you some context. In the past, recent past, I have been doing research on using ontologies for data quality in databases. Data quality is a very important problem in data management, and we want to assess the quality of data and also extract quality of data at query answering time. So we have done work on the use of ontologies for entity resolution. That is a problem of identifying and merging duplicates that are referring to the same external entity that is modeled by means of the database. Yeah. So in this work, that is a sort of inspiration for the current proposal project, is that we took seriously the idea that data quality is context dependent. That is something that everybody would say and accept, but is seldom used, put to work in practice. And I think that is something that has to be done. So we're starting doing something in that direction. So we formalize and use context for data quality specification. I mean, specifying declaratively what quality data are, and also using those contexts for assessing the quality of the data, and also for extracting data, quality data from the data source by means of this or through this context, formalized context. Actually, this idea of a declarative specification of a context that is also computable, I mean, from which we can do computations, is crucial in many applications. And so we have identified some of them in this project, and we want to address the issues that appear around them. So just to give a very simple gist, I mean, so we are thinking of what we are talking about when we talk about ontologies. Well, they are basically symbolic descriptions in some sort of logical language of domains in terms of concepts and relationships between them. For example, here we see something like warehouses in different countries or regions or whatever. Then some brands, I mean, sport brands in this case, like Nike. And then these are kind of concepts, right? I mean, warehouses or companies who are actually selling items to some stores or companies. And so we have basically concepts and relationship between them. And then this is what we usually call the knowledge graph. We have this, for example, Peter is a person, or Macy's buys from Peter. I mean, Peter, there is an arrow in this direction. So Peter is buying some items from Macy's, the department store, and Macy's is at the same time a company, and so on. So there are these directed arrows, I mean, connecting different vertices that correspond to elements of a concept. And in addition to that, we could extend this graph by means of rules, like this here. I mean, if we X sells to Y, then Y buys from X. I mean, the inverse relation. We can specify that by means of the rule. Or if X sells to Y, then X provides to Y, and so on. We are saying something like it provides is a transitive relationship. If X provides to Y, then Y provides to Z, then X provides to Z. So an indirect connection, and so on. And if X sells to Y, then Y has to be a customer because it is receiving some items. Yeah? So in this case, we have an ontology with the data. It's a very simple language, a rule language that I'm using here, but we can use more interesting languages. Actually, we could say that this language belongs to what is called data log, that is established language in relational databases since the early 80s, and so it is widely used. So basically, what we have here is a form of declarative, because it specify how things are by means of logic. We have a logic-based language or technique for knowledge representation through these kind of representations. And the idea is to try to use them in machine learning and explainable AI, another task that we consider in the project. But I'm going to focus only on a couple of tasks that we have in mind. Well, there are ontological languages. I mean, so this is a bit too simple as an ontological language. I mean, the idea is to extend, in our case, to extend this basic data language with other constructs using what is has been called in the last few years data log plus minus. That means we add a few things to classical data log, this is a classical data log program, but at the same time we impose some restrictions on the program so that we can really do computations. Yeah? I mean, hopefully in polynomial time, I mean, fast. Yeah. So let me give you a bit more of information about this kind of language, because I mean, it's important to convey the kind of language that we are thinking of. Another language that is used as well for creating ontologies is declarative, is description logic, and we are not going to use that. I mean, I'm not going to go into why we prefer this to the other one. This is for us, this is good enough. Okay. So, for example, we have an incomplete database D, and the idea is that this incomplete database can be extended, I mean, virtually or intentionally by means of additional rules. Yeah, that is the idea. We can impose, for example, restrictions or inclusion dependencies or integrity constraints. For example, saying that in this database, every manager is an employee. So as a data law rule, I mean, it's expressed like this: if X is a manager, X is also an employee. Another inclusion dependency: every manager supervises someone. So here we have something new. If X is a manager, then there is someone who is supervised by X. And here we have an existential quantifier that we don't find in data log. So this is a real extension of data log, and this is quite useful. Also, we have integrity constraints. For example, employees are not employers. So this is avoiding that an employee is at the same time an employer. So this is saying that X is an employee and X is an employer. That leads to an inconsistency that is represented by this propositional symbol. We also could have, I mean, functional dependencies, as usual in databases. I mean, expressed in this language, every employee is supervised by at most one manager. So this is saying if X supervises Y and X prime supervises Y, that means Y has potentially two different supervisors. Well, this is saying that they have to be the same. X has to be equal to X prime. So the minus in data log plus minus come from imposing syntactic conditions on data log programs. So not every construction of this sort is going to be allowed, because we would end up, I mean, running into horrible computational behavior in terms of complexity and runtime. So, and there are, I should say that there are also probabilistic extensions of these ontological languages, particularly for data log plus minus. So some of the ideas, very briefly, that I'm going to mention today is, well, have to do with a very important problem in machine learning, explainable AI, and many other situations as well, in data management, data analytics, that has to do with the inclusion and use of domain knowledge or domain semantics. I mean, if we have data, plenty of data, huge amount of data, we would like, for example, to convey some additional semantics about what those data mean, what do they represent. So this use of domain knowledge is something extra beyond the raw data. So we have to express that kind of knowledge. Yeah? So and in particular in machine learning, not everything has or can be learned from data. Now, there are things that are obvious for everybody who is processing data in some applications, and we could simply tell the system this is the case without having the system to discover very simple and trivial things, I mean, from the huge amount of raw data. Yeah? So to learn that loan applicants have accounts in a bank, a declarative logical statement would do. For example, if you have someone that has a certain amount of is requesting a certain amount of money for a certain kind of purpose, well, we can say right away that that person name, same here and here, must have an account at the bank, right? So that doesn't have to be discovered from the data. Yeah? We can say that right away, things like this. So important is to extract the more sophisticated and less explicit, I mean, knowledge that we may not be aware of. So there are different possible ways to combine domain knowledge with algorithmic approaches. So this is going, for example, going to be process the data by means of a machine learning algorithm, for example, neural networks. Well, this is what we call algorithmic approaches. And then domain knowledge is expressed by means of logical formula. So there are different ways of combining logical formulas with algorithmic approaches, both for semantics, to convey semantics, as I said, meaning about the application domain, and also for doing some sort of reasoning as well. The dependencies and also the causal relationships, you know, some features or variables influence other or cause a certain behavior on other variables. So they could be specified without making the system, the algorithm, to discover everything in the end that has to do with identifying the relevant features to represent and model our problem. We don't want to have redundant features. We want to have just those that are representative enough of the others that may be available. So this is the whole area of feature engineering. And I think this kind of semantic knowledge has a lot to do in this direction. Notice that we can express dependencies between variables and also causal relationships. In particular, if we use some sort of probabilistic extensions of this ontological language. Yeah. So this is better than trying to identify relevant features from scratch and from raw data alone. There is another area that has become very important in machine learning. It has to do with providing explanations for the results of algorithmic approaches. So actually, there are a couple of explanation scores that give a number that represent the relevance of a particular feature value when a certain entity is processed by a system. For example, if I have a client of the bank requesting a loan and the loan is denied by the bank, well, that user wants to know why that was the case, why the loan was rejected. Well, we can assign to different feature values that represent the entity, I mean the person who is applying for the loan. We can assign scores, trying to indicate how important those feature values were for this decision. And that is the beginning of some sort of explanation for the outcome that we perceive. Yeah. Most of these scores, I mean, like SHAP and REST, some more explicitly than others, are based on the use of counterfactual interventions. Counterfactual intervention basically are hypothetical changes of feature values that could potentially lead to a different outcome. In this way, we can identify in the end, by aggregating whatever happens with these counterfactual interventions, we can assign a score to the feature value at hand. Yeah. So, but counterfactual means changing things in the feature values, I mean, of an entity, but not all of those different interventions, changes of values make sense. So we could specify in a declarative manner what kind of counterfactuals are relevant or admissible. If we do that, actually, we could end up optimizing the computation of these scores, or we could end up basically changing the underlying probability distribution on the population on which the computation of these scores are based. Yeah? So the semantics can be basically brought down at the level of the probability distribution of the population. There are different ways to go, and we are exploring, of course. Another important use of ontology has to do with, well, why a certain outcome from a system is obtained is the end user. In this case, the person who is applying for the loan, or maybe the financial agent at the bank. Well, the important thing is that whatever we obtain as an explanation has to be usable, understandable by the end user. And that means providing an interpretation of that explanation. An interpretation, actually, they are strictly and closely connected with ontologies, because ontologies, in the end, they are describing interpretation instruction. So interpretability of results, that is important direction, interpretability of results and classification models or explanation mechanisms. The idea is to map those explanations of the scores into ontologies that are understandable by the user. In this case, this user ontology would be acting as a context, right? That can be used by the user to better understand the explanations that are provided by the system. You know? Well, I just touch 2 or 3 possible applications, but there are many other potential applications of ontologies in machine learning and explainable AI. And since we are in some way or one way or another combining algorithmic approaches with some sort of logical knowledge expressed by means of these ontological languages, basically many of these applications go in the direction of what is called are called neurosymbolic approaches to AI. So we could perfectly see our proposal, our project, I mean, fitting into this broader, I mean, context framework or area of neurosymbolic AI. Well, that is what I wanted to say for today. I hope I convey a bit of what we are planning to do and we will be doing in the next months. Thank you.
Thank you, Leopoldo. This is, I have to say, for me personally, very interesting and long. I mean, probably 20 years ago, I wanted to work in neurosymbolic and actually work a little bit on neurosymbolic computation because I think it's, well, a bridge between the 2 big divides in AI, that is symbolic artificial intelligence and, let's say, numerical or connectionist artificial intelligence or machine learning. So awesome. I think that Leopoldo should be connecting soon. So do we have any questions? Hello, Leopoldo. Hello.
Hello, can you hear me?
Yes, perfectly.
Okay, that's good because it's completely new. It has been really tough to connect.
I know. The only advantage I have is that I had to do it an hour before.
I don't know. He asked me all kind of questions if I want to update device anyway. Well, I think I will not touch anything because has been complicated. Okay, well, I'm happy to maybe make other comments or answer questions if there are any. I mean,
Awesome.
this.
Well, I wanted to start by emphasizing that this is all these projects in different degrees are also part of or under the umbrella of Inria Chile, no? So it's for us, is all of them are really important. And I think, by the way, if someone from the organization can tell me how much time do we have, because I know we are running late. I think it's going to be like 15 minutes. I don't know. But well, I think that I am not seeing any question from the audience. Oh, okay, from 5 to 10 minutes. So it's even. I have first a question for Cristobal. No, when you I don't know if you have. It's more like a comment, but have you? We are working here in other projects in something that is called physics-informed neural networks. That is essentially a neural network that I don't know if you have heard of it, but it combines the loss function with a term that is a classical loss function of a neural network, for example, quadratic error or something. And then the other term is the difference between the output of a neural network and what should be computed by a partial differential equation. So it's a way of making the two words combine. And when I saw your composite minimization problem, I think that maybe there are shared problems here, because we are working in, maybe I know that Hugo and Tago from Inria Chile are taking part of it, and maybe they can also pose some questions, but I don't know if it's like, have you heard of it? Have you heard of any application of this?
Hi, Luis. Thank you for the question. I'll just turn the volume off. So yeah, to answer. Yeah, so I think that, I mean, I don't know much about physics-informed AI, I know a little bit. I would say that at least the way you described it, conceptually, it is of a similar spirit, right? So you use data to train a model, but you're also, on the other hand, imposing a certain structure that is desired to achieve. And yeah, I mean, what we're doing in this project in particular, of course, is the more contrived setting of convex losses, but it certainly makes sense to think about situations where you may have loss functions which may come from non-convex settings or neural networks and so on. So I would be definitely open to learn more about it and see if it makes sense to use these algorithms in those settings.
We can hear you. We can hear you, Leopoldo.
Yeah. Okay. I wasn't sure, but I assume the question was not for me.
Yeah. No, it was from me to. It was actually a comment, because we're working on a similar, or let's say, parallel topic to what Cristobal was presenting. Very quick. The thing is that we are having a lot of numerical problems, because the two loss functions are like in completely different ranges, no, and have completely different numerical characteristics. So very easily one loss function like overcomes the other, and it's very hard to. You can put like a parameter lambda in the, but this is only like a patch. It's not solving because then what lambda, no, and then it's interesting. We have a recent paper on this. Maybe we can actually take it as a part of the project we have, and maybe discuss this even further. Thanks. Do we have any other questions? Let me check the chat.
Yeah, so Hugo was asking a question for me, actually.
Oh, go ahead. What is the question? Because
So the question is there any intuition for considering variational recurrent autoencoders? So what makes that architecture good among others? So I mean, basically, the idea of variational recurrent and the current neural network architecture in general is that they consider the sequence, right, in the data. So the other ones, like, for instance, variational autoencoders, just you can simply give them like a random set of data points, and it works fine. But in our case, we're dealing with light curves, and a light curve is basically the amount of light that we are receiving over time. So it's basically the way that astronomers call or name a time series, right? So for dealing with time series, we usually use recurrent neural network architecture. So because we need to somehow indicate to the architecture that these data points come first, and the next one comes later, and the next one, and the next one. So we had the best result in our work with using this type of architectures.
Thanks. I'm going to take a rain check here and have the conversation later, because actually it's a very interesting topic. How I think it's similar to what Mark was saying before, that how do you define correctness or proper use? It's even simpler how you define an anomaly, no? Because it has many contexts in which something is anomalous. And I think that in this paper we let's say took one approach to see if it worked, no? And it worked. Of course, actually we are like now testing with a lot more of variants and all of this. Also, awesome. Well, let me check if I see that there is one message here. Oh, thanks. Thank you. And I have one question for Leopoldo, because this is something that we, I am a matching. I would like to think that I am a neural network guy. No? I don't know if I am really but how do, like, in the context of this, let's say, relationship between let's say domain knowledge and database knowledge, in which directions do you think are the most promising, or that for you are the things people should look into? You are muted, by the way. It's probably the most used. Maybe I can unmute you. Let me see. No, I cannot.
Microphone. Okay, I think. Can you hear me?
Yes.
Okay. Okay. With respect to neural networks and explainable AI and logic-based knowledge, I think there are interesting directions to explore. One of them has to do with the fact that you can encode logic also in numerical terms. So basically, you could, if you want, bring into a neural network, numerical encodings of logic. That is one way to go. This has been done for the last few years. It's something that is not uncommon. What you have to do is basically to introduce norms that are suitable for logical knowledge, like T norms, for example, or fuzzy logic norms, fuzzy logic-based norms and numerical encoding. That is one way to go. Another way to go is to basically, you could start basically representing knowledge by means of declarative logic, and then you can basically transform those logical representations, for example, Boolean circuits, into neural networks. That is also something that has been attempted in the last, say, couple of years, with the particular purpose of exploring the applicability of explainable AI or explanation scores in that context. So I think people are working in that direction. I think there is still a lot to do. And I would mention a third, a direction that is also emerging and is very interesting. It has to do with making these logic-based formalisms, like, for example, logic programs, interact with neural networks. You have two components, the neural networks, and you have the logic-based formalism, and they interact. So that is also an interesting direction in these days. That's what comes to my mind.
Although actually we are running out of time. We ran out of time minutes ago. I propose you to.
Actually, I have to leave. I have to leave.
Awesome. Well, thank you, all of you. Thanks to the audience, and see you in another session later on. Bye.
Okay, gracias. Thanks a lot, Luis. Thanks a lot. Bye-bye.
Bye-bye.
Thank you all. Thank you to all the participants in this first scientific session. Thank you, Luis Martí. Thank you, Cristobal Guzman, also Hernan Lira, and also thank you, Leopoldo Bertossi. We close this way the first part of our first day. Next, we will leave you a link to log in into the Gather Town. This is very important. Remember, this is a networking space, and also you can see the posters of the interns who have been collaborating with Inria Chile. Let's not miss this opportunity to find out more of these new actors who are joining the panorama of science and technology. In 10 minutes, we will meet again on the second part of this first day of the Journées Scientifiques. Check your emails during the coffee break. Please remember that you must be registered in order to participate. If you have not yet registered, go to Journées Scientifiques 2022.inria.cl, and in the program there are some boxes highlighted in red. These boxes lead directly to the registration link for each of the 8 parts. You must register for each one separately in order to participate. Well, we're going to pause the transmission here and meet you again at the other link, remember, in 10 more minutes. So see you in the next part.